Hello, Teague Tigers. This is Miss Hall here. Today we're going to be talking about adding and subtracting fractions. This is a review of something you learned and practiced back in the first 9 weeks. Now, what I want you to do before we get started is pause the video and go get something to write with or write on so that you can work some of these problems with me. Okay? Go ahead and do that now. All right, we're back. Hopefully you brought something to write on. Okay, so let's review really quick how adding and subtracting fractions work. Okay, so for adding, first you add the numerators, and then your denominators stay the same. You want to think of your denominators as like your units, like when you're talking about 4 inches or $4 or 4 erasers. It's what you're counting. Think of it that way, and it'll help you remember that it needs to just stay the same. Okay, so we're going to start by adding our numerators. 2 eighths plus 4 eighths equals 6, what? 6 eighths. Okay, and subtracting is very much the same way. We're going to subtract the numerators, and then our denominator stays the same. So 7 ninths minus 2 ninths equals 5, but 5 what? 5 ninths. Our denominators stay the same. So you can ignore the denominators at first. Just do your simple fact math, and then just stick your denominator at the bottom. So now that we've got a review of how adding and subtracting fractions work, let's try some word problems with models. First, adding with fraction circles. Miss Hall baked an apple pie for dessert. She ate 1/6 of the pie. Her husband ate 2/6 of the pie. What fraction of the pie did they eat together? We can tell that this is an addition problem because they're wanting to know what fraction they ate together. This is an example of when it's a problem talking about eating, but it's not going away. It's not a subtraction problem. It's an adding problem. We're putting together the pieces that I ate and then my husband ate. Okay, so here are our two models modeling what we ate. So here's my 1/6 that I ate and the 2/6 that my husband ate, and we're going to put those together. Okay, so let's go ahead and add them. Add our numerators. 1/6 plus 2/6 equals 1 plus 2 is 3, and then our denominator stays the same. 3 what? 3/6. We could also solve it using the models themselves. We can take what's over here, my 1/6 from my pie, and add it on to the other pie. And here we see 1, 2, 3, 6. So you can either do the equation or you can use the models themselves. Okay, oops. All right, let's add with fraction bars. I forgot to tell you to take a second and try to draw the models. Go ahead and pause for a second and draw our models. Make sure that your bars are the same length and that all of the lines line up with each other. This is tenths. All right, hopefully you have your models drawn and shaded just like we have here. If not, pause it and do it now. Katie and Sarah were diving for toys in the pool. Katie found 4/10 of the toys, and Sarah found 3/10 of the toys. What fraction of the toys did the girls find? Okay, so this is an addition problem. We are putting together Katie's toys with Sarah's toys. So let's label our models really quick. What fraction does this show? This shows 4/10. And whose is that? So we have a 4/10. That goes with Katie. Katie found that 4/10 of the toys. What fraction is this showing? 3/10. That is showing 3/10 because 3 of them are shaded and there are 10 altogether. And who found those 3/10? Sarah found 3/10. That 3/10 goes with Sarah. Okay, so we're going to add together Katie and Sarah's fractions. So if Katie found 4/10 of the fractions of the toys and put it together with Sarah's 3/10 of the toys, let's add those. 4/10 plus 3/10. We think 4 plus 3 is what? 7, with our tenths staying the same at the bottom. So they found 7/10 of the toys. Now we could also use our models to help us solve this. Let's take the smaller model, in this case it's the 3/10, and move it up here. 1, 2, 3, we'll shade in. 1, 2, 3, and we'll just kind of ignore Sarah's now. So now there's 1, 2, 3, 4, 5, 6, 7 out of the 10. 7/10 is what they found. We can see it in the model and we can see it in our equation. Let's move on to subtracting. We're going to start with fraction circles. So go ahead and draw just one circle. Because for subtracting, we're not going to be putting two fractions together. We're going to be starting with some and taking away. So you're going to draw one circle. Let's read our problem. Jesus ordered a pepperoni pizza for dinner. The pizza was cut into 8 pieces, and he ate 3 of them. What fraction of the pizza is left? This one's kind of tricky because it doesn't show you any fractions, does it? But we can tell what the fractions are if we read the problem. So let's start by drawing our circle. So there's his pepperoni pizza. The pizza was cut into 8 pieces. So we want to cut it into 8 pieces. Eights are easy for me because I always do the little cross and then I exit. And then I'm left with 1, 2, 3, 4, 5, 6, 7, 8 pieces. And what do we call something that's been cut into 8 equal parts? What are these fractions called? Eighths. It's been cut into eighths. Ta-da! Here's a prettier one. So here's our pizza cut into eighths, okay? And he ate 3 of the pieces. So let's just cross out 3 of those pieces to show that he ate them. 1, 2, 3. And we can count what's left to see how much pizza is left. So we want to know what fraction of the pizza is left. So if it's asking for the fraction saying 5 pieces, is that going to be our answer? No, because it wants a fraction. Okay, how many pieces are left? 5. How many were there total? What fractional parts are these? These are eighths, so there's 5/8 of the pizza left. Now let's think about what that would look like in equation. What did we start with? We know eighths are our denominator here. How many eighths did we start with? 8 of them. 8/8 is the same thing as 1 whole pizza. And then we took away what? 3/8 of the pizza is what he ate. So what does that equal? 8/8, our whole thing, minus 3/8 equals 5/8 because our denominators stay the same, and 8 minus 3 is 5. So either way, 5/8 is our answer. Okay, let's go ahead and do another one. This time we'll use fraction bars. So let's draw a nice long rectangle before we get started, just because I know it's fraction bars. Ms. Hogue is cutting ribbon for a craft project. She cut an 8-inch section off of a 12-inch piece of ribbon. How much ribbon does she have left over? Which of these numbers is representing the whole thing? The 8-inch section or the 12-inch piece? The 12-inch piece is the whole thing. She cut the 8-inch piece off of that. So we want to cut this into 12 equal parts. Just do the best you can in cutting it up. Here's a nice pretty one. Okay, so what we have here is what we're starting with, the whole thing. We're starting with all 12 inches of the 12ths. We're starting with 12 twelfths. Okay, and then she cut off 8-inch section. 8-inch section off. So we're going to get rid of 8 of these inches. 1, 2, 3, 4, 5, 6, 7, 8. So that's the section she cut off, and so this is what is left. They wanted to know how much ribbon is left over. So here we go. What fraction is this? Yeah, I see 4 pieces out of 12 altogether. So we have 4 twelfths left over. Let's look at what that equation would look like. We started again with our whole 12 twelfths minus the 8 twelfths that we took away, and we are left with 12 minus 8 is 4, and our denominator stays the same, twelfths. Okay. All right, now let's combine our adding and subtracting with a 2-step problem. Fabiola and Catherine are working on a project for school. After 2 days, Fabiola finished 4/7 of the project, and Catherine finished 2/7 of the project. How much of the project do they have left to finish? We want to know how much of the project do they have left. Okay, in order to figure out how much they have left, we need to know how much they had finished together. Okay, so we're going to have to add first and then take away to see what is left. Okay, so take a second and draw your 2 bars to match this model. Make sure your rectangles are the same length and that these line up in 7 parts. Do you have your models drawn? Good. All right, now let's label these. What fraction is this one showing? That is showing 4/7. Who finished 4/7 of the project? Fabiola did. Fabiola finished the 4/7. So that one's representing what she did. What fraction is this showing? 2/7. According to our problem, what does that 2/7 represent? Right, that's how much Catherine finished. That is Catherine's portion of the project. Okay, so we know that we need to add them together to see how much they have left. So let's add Fabiola's 4/7 plus Catherine's 2/7, and we end up 4 plus 2 is 6, and our denominator stays the same, 7. 6/7 is what they have finished. Are we done? No, because they want to know how much they have left to finish. Okay, we can also do that on our model. Move Catherine's up here. And look, this is how much they have left. That's only 1/7 of the project is left. So what would that equation look like? Well, we would start with the whole thing. That with the subtraction, guys, you need to remember a lot of times you're starting with that whole. The whole in this case would be 7/7. It's however many pieces there are above itself. So 7/7 minus the 6/7 that they have finished equals 7 minus 6 is 1/7 of the project is what they have left. Okay, so guys, adding and subtracting fractions is really not that difficult. You just do your simple basic math at the top and you keep your denominators the same. All right, keep on practicing and have a great day, Tigers.